Hey guys, we're going to review parabolas and then expand on that to more Algebra 2 and conic skills. So we know this is a parabola because of the square, and it's vertex form because of the parentheses. So inside the parentheses is opposite what we think, outside is what we think, and so that means that my vertex is at 1, 3. This is our rate of change, and I'm putting that in quotes because it's not really our rate of change, but it helps us on like a multiple choice get in the right ballpark. So this has to go up to over 1, and then up to over 1. So for a rough sketch, that's what it looks like. This is called standard form. To get our vertex out of it, we have to first find the axis of symmetry. And that is x is negative b over 2a. So for this example, it would be negative 4 over 2a, which is 4 over 4, or 1. So this gives me the x part of my vertex. To find the y part, I go back and I'm going to plug in 1 and then solve. So my vertex is at the point 1, negative 1. And then my rate of change is this leading number again. So up 1, 2 over 1, up 1, 2 over 1. So there is a rough sketch of it. This new form is called general form. So we are still going to have the same vertex, and it's going to be opposite of what we think inside. So it's going to be 1, 1 for that guy, but this number in front is special. We are going to have a problem. It's always going to be 4 and it's always going to be p. And then the number outside the parentheses is what we put here. And we're going to solve for p. So when we divide by 4, p equals 1. So this is now our rate of change. Again, still in quotes. Okay? So I'm going to go to 1, 1. But what's unique is this y is what's squared. So it's going to go up 1 over 1, down 1 over 1. And it's going to open in like a C shape. Okay? I did that poorly. It should have been 1, 1, and then opening this way because it was positive 1. This would have been an example of negative 1. So if this was over here squared, it would have been our traditional parabola opening this way, but at 1, 1. So the new things that are going to move it into a conics level is we have a parabola, and we have to find this thing called the focus. The focus is there is going to be light that goes into like a telescope, into an eye contact, something with a curve. And it has to go through the focus for it to hit and then reflect. If it just goes straight in and doesn't go through the focus, it's going to go straight back where it came. But if it hits the focus, it's going to reflect and make some angle. So we first need to have to find out where the focus is and how to solve for that. And then there is this thing called the directrix. The directrix is the same distance from the focus to the vertex, from the vertex to the directrix. What the directrix is useful for is I have my parabola, and I have a light that shines through. This angle and this distance is hard to find. So what we can do is we can just say, where does it hit? How far is it from the directrix? And then we can use this measurement to say, this is how long this one's going to be, and this is how long it's going to reflect out for. So how do we find those? So our directrix is just 4p. So whatever 4p is. So in our first example, where we had y is equal to 2x minus 1 squared plus 3, what we have to do is we have to get the square on one side and everything else to the other. So I'm going minus 3, minus 3, divide by 2, divide by 2. So now I have 1/2 y minus 3/2 is equal to x minus 1 squared. So the squared is on one side, everything else is on the other. I really only care about the other variable now. So it's 1/2. It's what 4p equals, and I'm going to divide by 4, divide by 4. So p is equal to 1/8. So what that means is in our first example, I'm going to go 1/8 in front, and that is my focus. However far my focus is in front is also how far my directrix is in back. So now, let's say a light hits here, we can measure from there to our directrix to see how long of a wavelength that is, because this is a straight line and that's much easier to measure than a diagonal. Okay. So doing our next one, we had y is equal to 2x squared minus 4x plus 1. So I'm going to get the squared all by itself on one side. So I have y plus 4x minus 1 is equal to 2x squared, divide by 2, divide everything by 2. So I have 1/2 y plus 2x minus 1/2 is equal to x squared. So I have the x squared all by itself. Again, I just care about the variable different than the square, so y is opposite than x. And then it's 4p is equal to 1/2, divide by 4, divide by 4. For this example, it's 1/8 as well. So going to this one, I would go from my vertex, and I'd go 1/8 of an inch up, 1/8 of an inch down. So this is my focus, and this is my directrix. So let's say a light hits here. We can measure and say how long of the line was inside the parabola. And then the last example is y minus 1 squared minus 4x plus 1. So again, we want the square all by itself on one side, which is good. And then we're just going to take this number in front of the x. So it's 4p is equal to 4, divide by 4, divide by 4. So p is equal to 1. So that means our focus is 1 in front of the vertex. Our directrix is 1 below it over there. If you have any questions, email me, and good luck.